Fiber optic cable transmits light rather than voltage signal. This property eliminates the problem of electrical interference from transmission. Fiber optic cables can transmit signals at much greater speed and over much greater distances than copper cable. However, fiber optic cable installations are more expensive than copper cable installations. Fiber optic cables consist of a central core which guides light. A layer of cladding surrounds the core completely. The buffer coating provides mechanical protection and bending flexibility for the fiber. The core and cladding of an optical fiber cable are usually made of highly pure silica glass or plastic, depending on the type of cable. The refractive index of the core and the cladding are different in order to facilitate the passage of light through the fiber. The buffer coating is usually soft or hard plastic such as acrylic or nylon. Light travels in fiber optic cables by the principle of total internal reflection at the core cladding boundary. A fiber optic cable guides light in particular patterns called modes. A fiber optic cable, which has a very small core diameter, carries only one mode, which travels as a straight line at the center of the core. This type of cable is known as single-mode fiber. Fiber optic cable, which has a larger core diameter, can carry more than one mode. This type of cable is known as multi-mode fiber. The technician has stripped back about 3 meters of cable jacket to expose the fiber loose tubes and cleaned off all cable gel. Using a tube stripper, he is exposing the individual fibers. The fibers are now being cleaned. The individual fibers are now going to be secured to the fiber terminating tray using cable ties and will be arranged in the cassette, ensuring that the fiber's minimum bending radius is not compromised. The cassette is closed and the tray is slid back into place. The technician is now preparing the fibers for splicing. Both fiber ends are cleaved with a high precision fiber cleaver. The sleeve is being inserted. The fibers, together with the sleeve, are placed in the fusion splicer. Here we can see the fibers being aligned by the splicer and the splice being affected. What we are seeing now is a splice tray. The spliced fibers are now being secured together and placed on the splice tray. The technician will now loop the excess fiber around the guides of the splice tray.